All right. We'll talk about calculus today. Okay, why we need calculus for machine learning, okay? And then the fundamentals of calculus. Okay, we'll talk about it. So let's start with the example which I already gave, the multiplication example, okay? Where we try to find the number two. Okay, I mean, if you remember the example, the machine learning fundamentals, we were trying to find the function f of x, okay, that is equal to x into 2 by giving the input and the output, right? We wanted to find the value, I mean, we wanted to basically find the function. I mean, what should I multiply 1 with to get the answer 2? What should I multiply 2 to get the answer 4? Okay, and we were trying to find out using machine learning this number 2. Okay, this is number 2. So, how did we, I mean, go about it? We actually tried with random guesses. Okay, we tried with guess 1. Okay, like 1 into 1. Then the answer was 1. Okay, and then we found that we wanted 2, but the answer is 1. So the error is 1. Okay. Similarly, we had 2 into 1. The answer is, I mean, over for the guess 1, we got the result as 2, and the difference is 2. So what happened is we had to now increase or decrease this guess actually. So what we did is actually we kind of made a change. Like okay, let's say we'll try with 1.5. Now what happened is 1 into 1.5 became 1.5, 2 into 1.5 became 3, and the error reduced from 2 to, I mean, like 1 to 0.5, and the error reduced from 2 to 1. What is the error? The difference between these two. Okay, the what we wanted is 2, what we got is 1.5, so the difference is 0.5. What we wanted is 4, what we got is 3, if you guess 1.5. So the error is 1. But what is happening with the error? Okay, this is the error. What is happening with the error is decreasing. Okay, and then the next guess was 2, and the error became this prediction became 2, this prediction became 4, and the error became 0. Okay, so what it really means is we started with the random guess 1. We found when we incremented to 1.5, then 1.75, then 2, and we finally got the error 0. Now, what are we doing here is making some changes to this input. Okay, when you make a change, what happens to this output? When you make a change from 1, I mean, we started with 1, and then 1.5, and then 2. Every time we increment this guess from 1 to 1.5 to 2, we are making a change to the input and trying to find out what happens to this output. So calculus is all about dealing with these changes actually. Okay, so if you want to have a process by which you can find the impact of a change, whether it is positive or negative. Suppose if you had our initial guess was 1. Okay, suppose we had guessed the next guess was 0.5. Okay, instead of going to 1.5, if you guessed 0.5, what would have happened is this 1 into 0.5 would have become 0.5. Okay, the error would have initially the error was 1. Now the error would have increased to 1.5. Okay, we wanted actually 2, but if we had guessed started with 1 and then try to, I mean, reduce the value to 0.5, the error would have been like increased from 1 to 1.5. So whenever you see an increase in error, what we do is, okay, then we found that okay, probably the earlier guess was much better, so we come back to 1 and we go in the other direction. So we are trying to find out the value, I mean, the impact of a particular change we make here and the output, and try to evaluate the direction in which we wanted to take the next guess actually. Suppose if we guessed 1, if you guessed 1.5 and then 1.75 to 2, we are reducing the error. Suppose if we started with the guess 1 and reduce it to 0.5, then the error starts increasing. So okay, when the error starts increasing, we know that things are not going good. We kind of reverse and go the other direction. So this a process of trying to find out what is the impact of a particular change on the output. Okay, helps us to kind of gives us the intuition of which direction we needed to go next. Okay, to kind of find out what value should I change, and then to kind of narrow down the error and make it close to zero as much as possible. This process of dealing with changes is all about calculus. Now let's connect the dots. Actually, now this is why we are trying to learn calculus in machine learning. Now let's connect the dots here. Okay? Now let's put it in the graph. Okay, what is the multiplication table? Like 1 into 2 is equal to 2, 2 into 2 is equal to 4, 3 into 2 is equal to 6. What does it represent in a graph actually? So let's say this is like 2, 4, 6, 8. Okay, let's put it this way. Maybe 1, 2, 3, 4, 5, and here it is like 2, 4, 6, 8. So what does it mean? This is x, this is y. Sorry. This is the value of x, this is the value of y. Okay, the value of x is 1, the value of x is 1, this is y, let's say this is y. And the function f of x is equal to 2 into x. Okay, so that is the function. This is the function we are trying to find, which is equal to. So the value of x is 1, y is 2. X is 1, y is 2. The x is 2, y is 4. X is 2, y is 4. X is 3, y is 6. If you see here, eventually the function which we are trying to learn, okay, that is using the input and the output, we are trying to learn this function f of x. That is nothing but try to multiply x with 2. That is 2x is the function we are trying to learn machine learning to solve this problem. If you try to plot this, what happens is, and connect the dots. Okay, if x is equal to 0, probably the output will also be 0. So if you see here, it starts here and it forms a straight line. Okay, now if this, let me make it really straight. It's a kind of curve. Straight line, 2, 4, 6, and 4 becomes 8, 5 becomes 10, and so on. Okay, 5 becomes 10, and so on. So it's a straight line. Now, if you remember, what is the equation of a straight line? Okay, the equation of a straight line, if you remember in our school days, it's y is equal to mx plus c. Okay, if you see here what we have found out, y is equal to 2x, okay, plus c. The constant c is your intercept where it connects to the x-axis. Since it is connecting at 0, here our constant is 0. Suppose the intercept c is 1, the c is 2, the line would have been like this actually. Okay, but it would have a different function. Okay, see, 2x plus 2. So everything would have incremented by 2. Sorry, we have a heavy rains out there. Sorry about the thunder. Okay, now this is. I mean, we have converted this this problem which we try to solve. That is a multiplication table of 2 using machine learning, and we're trying to plot it here. Okay, in a graph. So 1 into 2 is 2, 2 into 2 is 4. 3 into 2 is 6. Okay, this is the line it forms, and this is the equation of a straight line. Y is equal to mx plus c, and if you see, m is the slope. Okay, when is the slope? So here the slope is 2, and intercept is 0 because it is starting with 0. So this is the equation. So if you now I use the term slope. Okay, what does slope mean actually? Okay, here I just told that m is equal to 2 here. Okay, how do you find the slope? Slope is nothing but a rise over run. Okay, rise over run. So what does it mean? For a unit change in for a unit change in change in x direction, what is the corresponding change in the y direction? So what it really means is that if I change from 0 to 1, that is the input. Okay, from 0 to 1, what is the corresponding change in the output? Okay, output changes to 2. Okay, if I change from 1 to 2, okay, the output changes from, this is the output actually. So let me put it this way. Okay, change in this is the change. This is the run. This is the rise. Okay, so if I change from input from 1 to 2, the run is 2. Okay, the run is 2. I mean, like, sorry, the run is 1. Okay, the run is 1. I'm changing the input from 1 to 2, the run is 1. What is the rise? It started with 2 and it became 4. So 4 minus 2 is the 4 minus 2 is the rise. So 4 minus 2 is 2. 2 by 1. Yes, that's the reason why the slope m is equal to rise over run. It is 2. That is exactly what we are getting here, and that is what we are learning here. So essentially, what we are doing in machine learning is trying to find the slope of this straight line, so that we kind of fit it. So if you had found a different line like this, different line like this, the answer would have been different, and it would have got a lot of errors. If you have found out the line like this, the answer would have been different, the error would have been different. So eventually, what we are trying to do is trying to find a line which with the slope 2 and which points pass through all the points with error 0. That is what we are trying to do in the machine learning. So now I introduced the word slope here. Okay, slope is rise over run. The rise is the number of units it changes for every unit. Change in unit of x direction. We will take one more example for to find the slope. Here I use this example to try to find 4 minus 2 is equal to 1. Now let's take a change from 2 to 3. Okay, 2 to 3 is what? One unit change. Okay, so basically I'm just making 1 unit change here from 1 to 2 to 2 to 3. So the run is 1. Okay, what is the rise? It has moved from the answer for, when it was 2 it was 4, when it was 3 it is 6, correct? So the change in the rise is 6 minus 4, which is equal to 2 by 1. So the slope is constant irrespective of whatever point I take. Okay, this is what is important when we try to talk about slopes. Actually, we are trying to find the rise over run, and the rise is the change in y, the change in y with respect to change in x. So whenever the change in y happens, there is change in x happens, there is a corresponding change in y. We are trying to find the ratio of it. So this is what is meant by slope, and it is pretty evident from the fact that we were able to find it using a simple formula of rise over run in the case of a straight line. Okay, so this is what calculus tries to do. Okay, since it is a straight line, we are able to subtract it the rise over run, and we are able to get the slope directly. We don't have to. We don't have to really. Think deep about calculus in this problem. Okay, at least in this example. Now let's extend this problem to a little bit more complex. Actually, now instead of straight line, okay, instead of a straight line, let's say we have.